we have one last task we need to tackle here, which is to write a dot equals method for our ArraySet class. Now I'm going to take this opportunity to also review the this keyword, the equal equals operator, and see how those are interrelated with the dot equals method. So to set the stage for the task here, the equals method, it takes two objects and it tells you whether or not I, one of those objects, is equal to the other. And just like all object methods, there is some default implementation, and we're going to need to override this so the equals works properly. Now, don't we already have the equal equal operator? Well, we do. And I'd like to remind you, I've mentioned this kind of offhandedly, but here I'm really going to call it out, that equal equals and dot equals are not the same thing. So what does equal equals do? Well, as an example, suppose we create two sets, one that has 5, 23, and 42, and we make another set that has 5, 23, and 42. If I check on this equal equals property between JavaSet and JavaSet2, I get back false. And the reason is that these two memory boxes do not contain the same bits. These are not the same arrow. They do not point at the same object. All three of those sentences are equivalent. Okay? So equal equals doesn't give you true here. The actual thing we're looking for is a semantic type of equality. So if I call dot equals, in this case, now, okay, things will be better and we get back true as you might expect. Okay? So if we want to test equality, we have to use the dot equals method. And to have a dot equals method, like for our array set, that means we're going to have to write a dot equals method because the default implementation actually just uses equal equals. And we'll come back to that in a minute. One little quick side note is that this is also true for arrays. So if I have an array that's 1, 2, 3, 4, and another array that's 1, 2, 3, 4, equal equals will consider them not the same because they're two different arrays. In that case, you'll use arrays dot equal, and that will compare the two arrays. Okay, just a little side. Okay, so let's dig in a little more. I want to return back and talk about the this keyword, and that'll help us understand the default implementation of the equals method. Okay? So recall that this is a reference to the current object. So an example from lecture 2 is if I am the dog class and I have an instance method called maxDog that takes another dog. If the size, my size, is bigger than otherdog.size, I'll return myself. And so in this case, this is a reference to me, the thing that's actually running the code. Now, because of, this is a little bit of a detour, but because this is a reference to myself, I can also use it to reference my own instance variables or methods. So at least in 2022, I kind of omitted this early, and so I wanted to raise this point while we're talking about equal equals in this. So unlike Python, where if I want to access my own instance variables or methods, I had to use self, or what's usually called self. And if you don't know Python, don't worry about that. But in Java, we don't have to actually say this. It's not mandatory. So in other words, if I say if this dot size is bigger than o dot size, that's exactly the same as just saying if size is bigger than o dot size, because Java infers that, well, hey, there's no size variable in this local scope, so I'm going to look at meat. Like that's who might possess the size, and so I don't have to actually say this. Okay. So if you've ever been a little confused about using this or not, it's optional in this case. Okay. Java infers when it's necessary. Now, one thing though is that if I have a naming conflict, so for example, I have a local variable that has the same name as an instance variable, then I need to use this in order to disambiguate. Okay? So imagine that we have a constructor for dog that has a parameter called size, and let's say the dog class also has a variable called size. Here, there's a name conflict. This variable is hiding the instance variable. Okay? So if I write this method size equals size, there's a name conflict. This is the purple situation. This does nothing. It just says local variable size equals size. Java does not figure out what you meant in this case. And so there, what you need to do is say this dot size is equal to size, and that will work correctly. So it's saying the instance variable is now equal to the local variable. Okay? So if you ever have a naming conflict, you can use this to disambiguate and say you mean the instance thing, not the local variable thing. Okay? Now, in the circumstance where the local where a local variable does not conflict, so for example, my constructor uses the character s or the name s for the constructor here. In that case, you don't have to say this. You can if you want, but you don't have to. Okay, just wanted to revisit that in case that ever seemed confusing to you. All right, so then back to our task, which was understanding dot equals. So below, I should note that on GitHub, you can actually see the code for all of Java. So if you want to look up how sets work or array lists or whatever, you can read it on GitHub. And Java's all written in Java. And so here, this method right here is the equals method for the object class. Okay, this is the default method you get. So here, pretty version on the slide is the equals method simply returns whether or not they are the same bits. Is my reference, my the same thing as the object? Okay? And so as we've seen, if we have two different sets that contain the same values, this doesn't give us the result we want. Okay? So what we're going to try and do then, okay, and now to really finally completely set the stage for our implementation, we have this equals method we want to write, and this is why we need to do it. So if I create two array sets that have 5, 23, and 42, and I print out the result of aset.equals aset2, I get back false. And the reason is that it inherits this default equals method, and these are not the same object, right? They're two different asets, and therefore we get back false. Okay, so that's what we're going to try and fix here. Okay. Now the way I've set this up in IntelliJ is I have a test array set equals class that I run all of its tests and does three things. First, it tests these two sets that are supposed to be equals, and I'm getting back false. Expected 5, 23, 42, but got 5, 23, 42. This seems kind of silly, right? This shouldn't happen. And then I also have two tests that ensure that not equal arrays are also not equal. Okay? Sorry, two not array sets are not equal. Okay? So our goal is to get all three of these tests to pass. All right. And so from the lecture code repo, you can try and write this yourself and see if you can pass these tests, but I'm just going to do it here myself. Okay? So how do we do it? Well, here's where I'm going to need to teach you a little bit of new syntax. Okay? So if I try and write this array set equals method, I'm going to need to somehow take the object that someone gives me, okay, and tell is it also an array set and is it equal to me. Okay? So the array set equals is going to be a little more complicated, so I'm just going to give you an example from the dog class, what a dog equals method might look like. So we'd say public boolean equals object O, and this tricky issue that the thing coming to me is an object and not a dog, we resolve by using this instance of keyword. Okay, here's an example. We say, if O, the other thing that's been given to me, is an instance of dog, then if my size is equal to the other dog's size, then we'll return true. Okay, that's the idea. And if the other thing is not a dog, then we'll return false. That's how to read this method. Now, your brain was probably glitching out a little bit because this is like weird syntax. So let me run through what instance of does. It does two things. First, it checks to see if O's dynamic type is dog. And then the second thing it does is it implicitly casts O as a dog into a variable called uttadog. Okay, so it's a little bit of a complicated thing to read, but basically a side effect of this instance of check is the creation of a variable called uttadog of static type dog that references this original object. Okay, and this will work correctly even if O is null. If O is null, this instance of will simply return false and we'll be good to go. Okay. Now this feature, this new instance of feature, this is pretty new to Java, and so the TAs just learned this in the fall of 2022. So be nice to them if they haven't seen it yet. Okay. That's a lot to digest. So let's jump in and actually write this array set equals method and see if this really makes sense as we interactively work with our code. Okay. So what I'm going to do is I'm going to say public boolean equals, and let's say I typed array set O. Okay. And then I add here override. Okay. I get an error saying you are not doing the right thing. You're supposed to override, you're not actually overriding a method from your superclass. And if you see this problem, it's because you have made the rookie mistake of putting array set here. It's supposed to be object. It really has to be object. Okay. If you don't have the right type here, and what will happen in practice is that this equals method will not get called often when you expect it to. Now, this is a little bit of a subtlety about dynamic method selection that we haven't really talked about in class, but suffice it to say, make sure you say object O, And luckily the override there tag is there to catch us if we ever forget. Okay. So what do we do next? Well, we want to check, is O an instance of array set? And then we'll pick a name, which I'll put here. I'll just say other array set, something like that. Okay. So if O instance of array set OAS, then do something. Otherwise, return false because it's not an array set. This is O is not an array set. So return false because I'm not allowing myself to be equal to anything else. You could change that though. You could say, well, maybe it's a list of some kind that has the same value, so I'll consider it equals. That's not how I'm defining it. An object will be considered equal to the array set only if it is an array set and has the same values. That's how I'm defining equality here. Okay, next thing I'll do is I'll check the sizes. So if the array set is not the same as my size, then I'll return false. And then I'll check that, so check sets are of the same size. And then I will check that all of my items are in the other array set. So if two sets are the same size and everything in me is in the other set, then we must be equal, right? So I'll iterate over myself. I'll say for tx in this, so iterate over myself. If other array set dot contains x, so if it doesn't contain, then I'll return false. So if at any point I find something in myself that's not over there, I'll return false. Otherwise, I will return true. Okay. And I think this should be fine. So now let's try running our test array set equals again. Yeah, pass all the tests. So now we are properly returning equals. And by the way, if you forget to do that, you'll fail the other two tests. That's why I have them there, or one of those other two tests. You can think about that later if you like. Okay. So that's what an equals method looks like in Java. Okay, we have an instance of call that casts this and checks its type, and then we do all the things we need to do semantically. Now you'll notice that ArraySet is yelling at me and saying, well, you have a raw thing of type ArraySet. We can maybe fix this by doing this funny question mark thing, but then we run into this other issue. So we could say T, but then we're going to run into an error here, and then it's yelling at me. So we're just going to stick with this raw type. I don't really want to get into all the little details of generics in Java, but this is how we're going to write our equals methods for generic objects in our class. Okay. All right. So this code here, this is the slide version of what we had in IntelliJ. This is pretty close to what a standard equals method looks like. There's one extra thing I did in the equals method on the slide, which is I first checked to see if this is equal to other. You might maybe pause the video and think about why we did that. I'll first say it's not for correctness. This doesn't make this doesn't change the behavior ever. Okay, the reason is that this is a efficiency optimization. So basically, if I am the same object as the other, then don't bother to iterate over the whole self, right? So imagine I am a set of 100 million things. I can avoid iterating over my entire self if I just check to see, at first, are we actually the same object? This is pretty common in more performant implementations of equals, but you don't actually have to have this for correctness. It just makes the method much faster in a limited number of circumstances at the cost of being slightly slower for all other circumstances. Okay? So this is just an optimization. All right, so that's how equals generally looks. Now I want to make a historical note, which is that before this semester, when I'm recording this, which is fall 2022, equals methods were uglier. They involved a lot of manual type checking, casting, and null checking. So you can look at the slides here from last year or in 2021, and that will show you that it looks something like this. So if null, return false. If we're equal, return true. If this class is not the same as the other class, return false. Do some manual casting, etc. Look like this. Okay. Now I should note that at least at the moment I'm recording this video, your teaching assistants, any academic interns, they're all taught in this old way. So because you'll talk to them, you're welcome to use either approach, either this old school explicit casting or this newer, better instance of approach, but I prefer the instance of approach, okay? So be aware that we are now transitioning to a newer style of equals method, and some folks may look at things the other way. All right, with that, we're done with the equals method, and you'll get practice with this at the end of project 1. a chance to actually write your own equals method. I know there's a lot of syntax and a lot of nitpicky details in today's lecture, but with that, you're ready to go and finish project 1.